Hello everyone, welcome back to Amit Education. So this is a chapter 5 of physics class 12, that is magnetism and matter. So this is the formula sheet, or you can say this is the short sheets for to revise the chapter. So let's get started. So first topic is magnet and magnetism. So magnet is a simple magnet is a material, a piece of a material that has both property, which both property attractive and directive. Attractive means to attract the small pieces of like iron, nickel, and cobalt, and directive means when we put a magnet in free, then it will subtend to the north south direction. यानी जो अर्थ का जो हमारा नॉर्थ साउथ पोल है तो उसमें जाके क्या हो जाती है, रुक जाती है. That is the directive property of the magnet. So this property of magnetism is called the magnetism. ये जो property है, this property of magnet is called the magnetism. तो magnet is the material and magnetism is the property of the magnet. Okay. Now next, what are the basic property of the magnet? So there are four basic property of the magnet. First one is the attractive property, which I already told you that a magnet attracts a small piece like iron, cobalt, and nickel. And directive property is when we freely subtend a magnet uh, aligns itself nearly in a geographic region, then it will stop in the north-south direction. It will always move to the north-south direction. Next property is the like pole always repels each other and unlike poles attracts each other. Next is the magnetic pole exists in pairs, means there is always north and south pole, and if there is south then there is a north pole also. They cannot exist in a single form, like single north, south cannot exist in nature. Next property is the magnetic field. What is the magnetic field? So the space around the magnet, this is the magnet, and the space, this is space around the magnet within which it influence like force can be experienced by any material is called its magnetic field. So the space or the area around a magnet is called magnetic field, where a object can feel its influence like uh, attraction or repulsion. Next is magnetic poles. So what is magnetic pole? So it is a region where the magnetic strength is maximum. The attraction or repulsion is maximum. It is called magnetic poles. So it is written there are the reason of apparently concentrated magnetic field. It means a strong magnetic field in a magnet, the where the attraction is maximum. वहाँ क्या होगा, attraction हमारा maximum होगा, which are called the magnetic poles. Next is Coulomb's law of magnetic force. Like charge, uh, magnet also have the Coulomb's law. So the force of attraction or repulsion between two magnet, where we written two charges. For charge, we write here two charges. So the force of attraction or repulsion between two magnet pole is directly proportional to the product of their pole strength. Qm1 and Qm2 are the pole strength of the magnet and inversely proportional to the square of distance between them. Suppose the square is r, then it is inversely proportional to the square of distance. That means square means r square. So it is inversely proportional to the r square. When we remove the proportionality constant, we will get a constant mu naught upon 4 pi. And mu naught is the permeability of free space. Okay. So this is the formula for Coulomb's law of magnetic force. Next is magnetic line of force. So it is the basic, it is defined as the curve, the tangent to which at a point gives the direction of magnetic field at that point. Suppose this is the magnetic field line, then at this point we will draw a tangent. This will show the direction of the magnetic field. So these lines represent that in which direction magnetic field goes. Next is the properties of magnetic field line. So the magnetic field line of a magnet form continuous closed loop, like they are out in the north pole and into the south pole. So it will create a loop. So always magnetic field lines create a continuous closed loop. Next is the tangent to the field line at a given point gives the direction of the net magnetic field it will at that point. So I'm already said that at this point, if I'm drawn a tangent here, this will show the direction of the magnetic field at that point. Next is the larger of the number of field line crossing per unit area, the stronger is the magnitude of the magnetic field. जितनी ज्यादा क्या होंगी हमारी magnetic field lines होगी जैसे in this area we have a lots of magnetic field line. That means we have the strong magnetic field. If magnetic field lines are less, then value of magnetic field is also less. Last property is magnetic field line do not intersect each other. Why? Because if they will intersect, at the point of intersection, there are two values exist for the magnetic field, which is not possible. So, magnetic field line do not intersect each other. Next is the formula sheet. This is for the magnetic field of a bar magnet at axial point. तो axial point पर magnetic field की value mu naught upon 4 pi 2 mr upon r square minus l square का whole square. And for short magnet, we can say L is very, very less than R. Then we can neglect L square. Then R is cut from R and we will get B actual equal to mu naught upon 4 pi into 2m upon R cube. And at equatorial point, mu naught upon 4 pi m upon r square plus l square power 3 by 2. Here for axial point, we will get r square minus l square power 2. And for equatorial point, we will get r square plus l square power 3 by 2. Okay. And for short magnet, we will say that L is very, very less than R. Then we will neglect L square and we will get mu naught upon 4 pi m upon R cube. So we can say that at equatorial point, at equatorial point, the magnetic field is half of axial point. Okay? So this is the formula for magnetic field at axial point and at equatorial point. Next is the torque. So torque on a magnet in a magnetic field is given by torque vector equal to m vector cross b vector. Next is potential energy of a magnetic dipole in a magnetic field. It is given by minus mb cos theta 1 minus cos theta 2. And for potential equal to 0, it is possible when m vector and b vector are perpendicular to each other. So in this case, u equal to minus mb cos theta we will get, and we will say minus m vector dot b vector is the value of the potential energy at that point. Next is Gauss law in magnetism. So, what is Gauss law? So, the net magnetic flux. Flux is what? Number of magnetic field line passing through a particular unit area. So according to Gauss law, the net magnetic flux through any closed surface is always zero. So, this is the closed loop for or the surface area. Okay, so it will become zero. So net flux is become zero for the Gauss law. Next is magnetizing field. Magnetizing field, the magnetic field that exists in a vacuum and induced magnetism. क्या कर रहा है वैक्यूम में रखा और क्या कर रहा है मैग्नेटिज्म यानी दूसरे जो मटेरियल है उनको क्या कर रहा है मैग्नेटाइज करने का काम कर रहा है सो इट इज कॉल्ड द मैग्नेटाइजिंग फील्ड द मैग्नेटाइजिंग फील्ड सेटअप इन अ सोलेनॉइड हम इसको सोलेनॉइड के अंदर सेटअप करते हैं इट इज कैरिंग कंडक्टर करंट आई इसके अंदर हम क्या कर रहे हैं करंट आई फ्लो को फ्लो कर रहे हैं एंड दैट इज प्लेस्ड इन अ वैक्यूम सो फॉर दिस magnetic field is given by B naught equal to mu naught and I. Next is magnetism or intensity of magnetization. So it is the magnetic moment developed per unit volume of a material when placed in a magnetizing field, यानी हम जब उसको क्या कर रहे हैं मैग्नेटाइजिंग फील्ड के अंदर रख रहे हैं तो कितना मैग्नेटिक मोमेंट डेवलप हुआ पर यूनिट वॉल्यूम में, दैट विल कॉल्ड द मैग्नेटाइजेशन. So it is a vector quantity and it is represented by capital M. So capital M equal to small m upon V. So this is the small m is the magnetic moment and capital V is the volume. So magnetic moment developed in per unit volume is called the magnetization. Next is magnetic induction. So if the total number of magnetic lines of a force uh, crossing per unit area through a magnetic material, क्या है ये? It is the total number of magnetic field force line. ये कितनी force lines पास हो रही है per unit area. ऊपर बात की थी volume की, and here we are talking about the area. So particular material. So its unit is Tesla and P equal to, the formula is given by mu naught into H plus capital M, and value of H equal to B naught upon mu naught. Next is magnetic susceptibility. It is the ratio of intensity of magnetization and magnetizing field intensity. It will denoted by chi m. Okay, so chi m equal to capital M upon capital H. And here are two important formulas. Mu equal to mu naught into 1 plus chi m and mu r equal to 1 plus chi m. Okay. Next, last topic is the classification of magnetic material. या फिर हम बोल सकते हैं types of magnetic material. So that are three type of material exist: diamagnetic, paramagnetic, and ferromagnetic. So diamagnetic are substance when we placed in a magnetizing field. यानी किसी magnetizing field में हमने रखा, they get magnetized in opposite direction of applied field. अगर मैंने मैग्नेटाइजिंग फील्ड ऐसे लगाया तो वो अपोजिट डायरेक्शन में क्या हो जाएंगे, मैग्नेटाइज हो जाएंगे. सो दीज सब्सटेंस आर कॉल्ड डायमैग्नेटिक सब्सटेंस एंड दीज सब्सटेंस आर रिपेल बाय मैग्नेट. ये क्या करेंगे, मैग्नेट से रिपेल होंगे एंड टेंड्स टू मूव स्लोली, स्लोली मूव करेंगे फ्रॉम स्ट्रॉन्गर टू वीकर पार्ट ऑफ अ मैग्नेटिक फील्ड. ये कैसे मूव करेंगे, स्लोली. They move slowly from stronger to weaker part of the magnetic field. Example is copper, lead and silicon, nitrogen and water, NaCl. और ये जो नाइट्रोजन है, ये जो स्पेशल गैस है, ये क्या होगी 8 sp पर. ये सब हमारा जो बिहेवियर है डायामैग्नेटिक का ये शो करेगी. नेक्स्ट इज पैरामैग्नेटिक. सो व्हेन दीज मटेरियल आर प्लेस्ड इन अ मैग्नेटाइजिंग फील्ड, they will get magnetized in the direction of applied field. Here diamagnetic are magnetized in opposite direction and they are magnetized in the same direction of the applied field. And these substances are attached by magnet and these are repelled by the magnet and they tends to move slowly and from weaker to stronger, but they are moved slowly but stronger to weaker. So these are the difference between them. So they will tends to move slowly from weaker to stronger part of the magnet. Examples are aluminium, sodium, calcium, and oxygen. And oxygen is a special case. It will behave it STP like a paramagnetic substance. And another example is CuCl2. It means copper chloride. Last one is ferromagnetic substance. So when we place this substance in a magnetizing field, they get strongly magnetized. These are magnetized, but this is only strongly magnetized in the direction of the magnetic field. It is magnetized in opposite direction and paramagnetic magnetized in the direction of applied field, but ferromagnetic is uh, in the direction of the magnetizing field, but strongly. It will behave strongly. So such substance tends to move quickly. These are move slowly. Okay, slowly. Here it moves slowly from stronger to weaker section, and it moves slowly from weaker to stronger section. But it will move quickly from weaker to the stronger part of the field. Example is iron, nickel, copper. Fe को हम क्या बोलते हैं, फेरस भी बोलते हैं. That's why it is called the ferromagnetic substance. आयरन की वजह से ये मैग्नेट की जो सबसे बड़ी प्रॉपर्टी है वो हम हम बोलते हैं कि जो आयरन से बने मटेरियल्स हैं दैट आर अट्रैक्टेड बाय द magnet. So it is called the ferromagnetic material because they are strongly magnetized. Okay, so this is the last topic of this chapter. So this is the formula sheet for this chapter. So here we end this chapter. Okay, so if you like the video, please share and subscribe. Thank you for watching. We will meet in next video.